Hi, and welcome to our session on what's new in Android development tools. I'm Jamal, a product manager on the Android Studio team.
And I'm Tor, and I lead engineering for Android Studio.
Today, Tor and I will talk to you about three things. First, I'll walk you through some of the features you might have missed since we last spoke with you. And then Tor will give you a demo of some of the latest features. And lastly, I'll conclude by going over a few additional product updates. Okay, let's take a look at the roadmap. First, I would like to remind you that we treat quality as a feature and continue to focus on product quality. To note, since I/O last year, we have fixed over 1,600 reported or observed bugs, fixed 20 UI hang issues, and 12 memory leaks. Working on these quality issues means sometimes new features take longer to reach the stable channel. But we think this is a fair trade-off since we want to make sure we deliver high-quality tools that make you productive. Next, I'll talk about Android Studio Bumblebee that we released to stable at the beginning of the year. In this release, we launched a new device manager which allows you to see a complete picture of all connected devices to the ID, both physical and virtual. Next, we added preview support for animated vector drawables in the design tools. And lastly, we finally added stable support for pairing your device with ADB over Wi-Fi. Overall, this was a slightly big release, so I just highlighted a few of the major changes. Up next is the Android Studio Chipmunk release that just landed into the stable release channel. For this release, we created a new way to preview compose animations. Additionally, we added jink detection to the Android Studio profilers. Overall, Chipmunk was a smaller release because we took a step back on features and spent even more time on quality and focus on polish and stability. Now, alphabetically, this brings you up to speed on our latest releases, Android Studio Dolphin Beta and Electric Eel. Instead of talking about these features, I'll have Tor walk us through a demo.
Today I'm going to show you a number of features we're actively working on for Dolphin and Electric Eel. And just like last year, I'm going to begin with build because we know from your feedback that that is an area of top concern. So let's start with the build analyzer. It tells us that we should turn on configuration caching, but that to do that, we'll have to upgrade our Android Gradle plugin version. We're always working on performance, so the easiest thing you can do to improve your build speed is to stay up to date with the latest versions, not just of AGP, but the Kotlin compiler as well, and probably other plugins. Here we can choose the version to migrate to. It suggests the most recent stable version, but I want the latest and greatest, so I'm going for it. So now it runs a sync, and if we look at the changes, you can see it has updated the DSL, and it also updated the version of Kotlin. The latest AGP requires a higher minimum version of Kotlin, but I'm going to go even higher to 1.6.20. So now that it has synced, let's try a build. We know that not everyone has been using the build analyzer, so we're working on this smart tooltip here, which shows up if we can cheaply detect that it has new suggestions. So let's take a look. Okay, it suggests that we try to get rid of the Jetifier. So let's try that. So it builds looking at transitive dependencies, and here it shows that we depend on a library which still requires the old packages. So let's double click and take a look at this dependency in the editor. And we have an error. And this actually has nothing to do with the Jetifier check. As you can see from the quick fix, this is actually a lint check related to the new Google Play SDK index, which we're launching at I/O. We're working with SDK publishers such that we can flag versions of libraries you're using that may have safety or reliability problems. And with the Studio integration, you find out about these issues as early as possible, not just when you go to publish the APK. And here I'm lucky because there's a newer version available, so I'll just switch to 21. And let's try the Jetifier check again. This time it's all good, so we will disable the Jetifier. A lot of projects still have this flag set to true because we put it in by default in new projects, but by taking it out, you can expect a 5 to 8% increase in incremental build speed. We've even seen up to 40% in some cases. Let's also run the configuration cache check, and this also now passes. And configuration caching is something we hope to turn on by default soon. We're getting all common plugins to be compliant, and we're getting close. The last thing I'll highlight in the build analyzer is this new download section we're working on. If we detect network traffic during your builds, we will surface it, and this can be really useful if your build is slowed down by misconfigured repositories, unnecessary redirects, excessive retries, etc. And we have plans to expand this quite a bit. Another build speed related feature we don't suggest in the build analyzer but probably should is the refactoring to migrate to transitive R classes. It's not particularly useful in a small project like this one, but what it does is update your code to use namespaces for each R class, which means AGP doesn't have to duplicate the resources into the app R class at build time. It does make accessing the resource from other modules a bit more verbose since you use fully qualified names to the R class, but in Kotlin code, we can clean things up by using import aliases. Anyway, it's not for everyone, but the refactoring should make it easy to try the setting to see if it makes a meaningful difference to your project's build speed. Another frequent request was for us to make lint both cacheable and incremental in AGP, and now it is. So if I just run lint after having run it before, you can see it's fully cacheable. But if I go in and add an unused string and run lint again, and let's look for the lint tasks, you can see that most of the lint tasks were up to date and it only recomputed the new affected modules. So running lint incrementally in your CI server should run a lot faster now. And that's also the case for instrumentation tests with the emulator. Instrumentation tests are more powerful and accurate than unit tests because they run a real Android environment. But historically, they've been very slow and cumbersome to configure. You have to do manual setup of emulators on the test machines. They take much longer to boot and run and so on. But with our new Gradle Managed Devices feature, we're working to solve this. And here's how it works. In my build.gradle file, I specify device configurations I'd like my test to run on. So here I've picked a couple of different device types, Pixel 2 and Nexus 9. This just implies things like screen sizes. I've also picked some API levels, 30, 27, and 29, and whether I want just the AOSP image of Android or if I want to include Google services. We've also created a new type of system image, an automated test device, or ATD for short. These are specially optimized to run tests. They don't include things that your tests probably don't need, like the Settings app, Gmail, Google Maps, and so on. Note that I don't have to go and pick a specific system image. In Studio, when you download system images, you probably wondered which image to get, 32-bit or 64-bit or x86 or ARM and so on. And here we'll automatically pick it for you based on the machine where the test is running. And by the way, in my case, it'll pick ARM64 because I'm doing this demo and running Studio on an M1 chip. Supporting this new hardware was a highly requested feature last year and it's stable now. And we backported system images as well, all the way back to API level 24 so far. So anyway, these device definitions will create a number of tasks. So for example, the ones for the Nexus 9 device are these tasks right here. And I'm now just going to run the Nexus 9 instrumentation tests. And it finishes almost immediately because I've already run this task before. But let's go and break one of these tests. I'm going to change this to off, which is false. And now when I run the test again, you can see that within a couple of seconds, the tests are running on the device. Notice how, even though this is an instrumentation test, how quickly it was up and running and failing. It's obviously booting the emulator from a snapshot that it was reusing. And this is great for CI. Everything is managed automatically. So here we've configured this project to run as a GitHub action. You can see here how we're invoking the Gradle commands with some extra flags to configure sharding, which can also help the test run faster overall. And if I switch to a build log where we ran the tests, you can see it in action. It downloaded the system images on the fly, accepted the licenses, etc. Let's switch gears from build speed to application speed. Jetpack Compose is our new UI toolkit. And unlike the old View system, which comes bundled with a system image, here the entire toolkit is bundled with the app. So we had to make it launch faster before we could launch Compose 1.0, and we did, and that's called Baseline Profiles. And recently we've generalized it to work with your custom app code as well. So let's take a look at this in the APK Analyzer. So here's the release APK for this app. So if we go to the assets folder and the DexOpt subfolder, we will find this baseline.prof file. This is a binary file decompiled here by the APK Analyzer, which lists methods that are hot and should be precompiled at install time by the Play Store app. This all happens automatically when you build release variants. We ship these baseline profiles with the Compose libraries, and the Gradle plugin merges them into your app. But you can even customize this for your own specific startup code path. Here's how this works in this app. This is a benchmark test which runs a core scenario to start your app. It'll create a baseline profile file, which you then pull from your device. You can then check this text file into your source tree, and then the Gradle plugin will handle the rest. But note that baselines are only there for release variants. They're not really relevant at debug or development time. So be careful not to draw conclusions from debug builds, especially when you're looking at performance. And so we're working on a new feature in the profiler to help with this as well. So in the past, the profiler required debuggable builds, which meant you were measuring something not entirely representative of what you'll ship. Soon you'll have a drop-down in the toolbar profile button to launch profiling without debugging info. And here I'm also running on a real phone, because for profiling, make sure you test on a representative device with the same ABI, and so on. So once the app is running, notice how it tells me that not all telemetry is available, such as the network inspector. We collect less information, so you're missing some insights here, but that also means that the CPU profiles you are getting are more accurate because you're really measuring what's happening in production builds. Another new profiler feature already available in Canary is jank profiling, or finding UI where some of the frames are laggy. And now you can see there's a whole new janky frames section in Systrace. I'm going to click on one of these frames, and I'm also going to press M to focus my attention just around this time interval. We can see that the actual duration here was 30 milliseconds, even though our budget was 20. I can turn on the life cycle of this frame as well, going through the different phases. And I can also turn on other frames that are in the pipeline around it. So here it looks like the RV scroll took a long time. You can see that its average is about 1 millisecond, but here it took 17. And RV scroll is a trace from the Recycler View widget, so that's where I would go investigate next. And note that jank profiling requires Android 12 to get all the necessary accurate data to capture the frame lifecycle like this. Another top investment area for us is quality. As Jamal mentioned, we've been focusing on fixing bugs and freezes, but we've also taken a hard look at some features and to rework them from the ground up. And one of those is Logcat, where you see your application logging output and crash data. The first thing you'll notice is that the data presentation is much cleaner. We're using colors to distinguish tags and different severities, for example. You can also get a much more compact presentation. We'll switch to the compact view. Here we've taken out dates, process IDs, and package names. Or you can customize both of these modes. For example, here in the compact view, I can get rid of the time and perhaps include tags, but without repeating them. And all of this is, of course, persisted across IDE sessions. There's also much improved filtering. By default here, we have a filter which matches for the current app. And it's smart enough to figure this out across multiple runs. Everything we're seeing here is my own app, but if I clear the filter, I can see all the output from the device. This syntax is part of a new query language to help with filtering, and you can hit Control Space for completion. You've already seen the package mine filter, which is a smart filter for everything pertaining to your app. You can add to the filter. So for example, to just look for network traffic from OKHTTP, we can add that in. And here, both conditions must be true. Is from my app and mentions OK HTTP. We can also search by tag, and we have completion for that. And if you repeat the same qualifier, it's interpreted as an OR. So here we're looking for either of these two tags. You can also add negation. So here, for example, we're subtracting out some matches. We can search for messages that are less than 3 minutes old. We can search for errors only, or we can search for stack traces only. So that's the new Logcat window, which is experimental in Dolphin. Another core area we're improving is device management. So we introduced the embedded emulator last year. And the next thing we're doing with this is allowing you to embed physical devices as well and control them from within the same window in Studio. So now I'm going to plug in my physical phone here. And when that pairs, we can actually see that in the running devices menu here, we can actually switch to my phone. So this is me interacting with the physical phone from the screen, or of course I can do it from, now I'm doing it on the computer with the mouse, and you can see the phone is reacting. And I've also paired my tablet here using ADB Wireless, which as Jamal mentioned is now stable. And I can connect any device that is Oreo or above, so API level 26 or above should work. And this makes it really easy. And just like with the embedded emulator, this makes it really convenient to code and test your app on your physical phone. You can keep your hands on your keyboard and or trackpad. In the device manager, we've also improved Wear pairing. You can right-click on a virtual watch and initiate the flow to pair it with a phone. This can be a physical phone, as I'm doing here, or it can be a phone emulator. This helps you during development set up your virtual watch as a companion to either a phone emulator or your real phone. It then walks you through the flow of setting things up. So now it wants me to finish the flow on the phone here. We've also improved the run configuration support for Wear and the underlying run config machinery. You can now easily run tiles, watch faces, and complications. Here's a simple tile. I can click the run button. You can see we now create a new special Wear run configuration, and we launch this tile right there on the watch. And once your Wear app is up and running, we now have a dedicated Wear toolbar. As you can see, I can now easily simulate clicking the buttons of the virtual watch, or tilt it, or even simulate placing my palm over the watch. And while we're on the topic of the emulator, a top request for many years has been support for Bluetooth, and I'm very happy to announce that we are working on it. So here I'm running a system image for Android T on the emulator, and I've installed a Bluetooth inspection app. From a terminal, I can now create a virtual heart rate monitor. Why not a real one? Well, our intention is that this Bluetooth device is something you're actually driving from an instrumentation test. So if you're a fitness app, for example, you can have tests that are driving your Bluetooth functionality in your app in a predictable way. We're still making this feature and the Bluetooth device API, but it's looking promising. We're trying to improve apps on large screen devices, and another major emulator feature to help with this is the resizable emulator. At first, this looks just like our normal emulator, but there's this magic toolbar button to switch screen sizes. So let's switch to what this would look like on a foldable. After a couple of seconds, we see the effect. And this is not just some simple trick where we just poke at the layout and force it to the new size. This is done at the Android OS level. So as you can see, the system navigation bar has appeared and the app itself has responded. Now the navigation buttons have moved from the bottom of the phone layout to the left, as they would be on this form factor. And if we switch to tablet, you can see again that the app has a different layout that it responds with. So by simply running on this special virtual device, I can much more easily test my app for different screen sizes. Note, by the way, that the first time you open each screen size, it takes quite a bit longer than what you see here. But don't get discouraged, it gets much faster after that. Just save your emulator snapshot after you've warmed up all the different screen sizes. Another feature we've added to support large screens over in the layout editor is called Visual Lint. Here's an older version of the Google I/O conference app, and I'm looking at some of the layouts. I can open up the layout validation window, and here I can see what this layout will look like across some different screen sizes all at once. We also run some analysis on these layouts to look for common problems, hence the name Visual Lint. So if I bring up the Issues panel and click on the first warning, it tells us we have a bottom app bar here that's being used for tablet screens, and they don't belong there. As we saw in the emulator demo, Gmail handles this correctly. As another example, it finds that for larger screens, this layout ends up with very long text lines, which is not good for usability, and it suggests we should split this up into a multi-column layout. And it's not all about large screen guidance. For example, it also warns us here that for one of the text labels, we don't have enough contrast between the background color and the text. Right now, this tooling is specific for the old View system, but we plan to adapt this for Compose as well. And turning to Compose, here's this app which aggregates news stories relevant to Android developers. When we shipped the initial Compose support, we included a feature which lets you update your strings and numbers immediately without a recompile to help you quickly make minor tweaks to the app. Many users are not aware that this doesn't just work for the preview, it works for running apps on devices and emulators as well. So here I am running the app in the emulator, and now I can start editing some of the text. So if you look at the label up here, what you're interested in, I can write select topics to follow. And notice that the running app is updating nearly instantaneously. I can make other tweaks as well. I can go, for example, change the padding, or maybe change the font size, and maybe even change the color here. So I can make minor tweaks to the UI, but we've been working on broadening this to support any edits inside your composables, and we call this Live Edit. So we'll add a button. So we can see our blank button top left corner here. We'll put a label on it. And then let's create a state object. Mutable state of click me. And then let's change our button label to be the state's value. And last but not least, we can make the state, we'll append an exclamation point whenever we click it. So now if I'm clicking the button, you can see that the label updates. So very trivially, while the app is running, we can go and tweak the code here. Let's take a more realistic example. This app is a news reader, so let's pick some topics to read. And here's the feed. It looks nice and readable. But remember the resizable emulator? Let's see what this looks like on a tablet. That's not great. As we saw in Visual Lint, you don't want the text to stretch across the screen like that. And the suggestion was to switch to columns, so let's try that. So I'll switch to a lazy vertical grid. And now we need to supply columns. 3 columns. Yeah, that looks pretty good. Let's take a look at our foldable to see how this looks. No, we need to make the column count depend on the width. So we can switch to Grid Cells Adaptive. The width should be probably 300. If we now switch to tablet, let's maybe go with 400. Yeah, that looks pretty good in the tablet size. Let's check phone. All good. All right, so one last thing for Live Edit. Let me just change the width here to, let's say, -1 dip. And the app crashes. I wanted to include this so you have the right expectations for this feature. When we're patching your running app on the fly, we can end up writing buggy code that causes the app to crash. Live Edit doesn't and can't know that -1 isn't a valid argument to this constructor. We're looking into adding some automatic safety and recovery machinery for some scenarios, but in general, as you play with this alpha feature, the workflow is that occasionally you need to restart your app, or we will restart it for you. But hopefully, it's a huge accelerator for that iterative development as long as you're aware of its limitations. And it's still a work in progress, but we're pretty excited about it and look forward to hearing your feedback from your own usage. All right, next, let's take a look at Compose Preview. With the preview, I can pretty easily see what each composable will look like under a number of different conditions, with different light or dark theme, device orientation, screen size, and so on. We can also pass in different data, a bit like a spec for the composable. You can repeat multiple preview annotations to have multiple previews for a single function. And here's a new feature in Compose 1.2. You can actually extract these preview annotations into its own multi-preview annotation. So I'll just go ahead and create a new class here, my devices, and then I'll put my devices as the preview annotation in place of these individual annotations. And now I can just reuse this single annotation throughout my project. I don't have to repeat my configurations over and over. So I'll just replace my individual preview annotation with this multi-preview annotation instead. We've actually brought Live Edit to the preview as well. It's not immediate like it is when you're editing a deployed app. There's a bit of a trade-off. In the preview, we're currently not maintaining a running app. We're recreating the layout environment each time, so it takes a second or two to render, still much faster than incremental builds before we had Live Edit, but it's running the same patching code we have on the device for Live Edit. As an advantage, because we recreate the whole compilation unit, this means you can make structural changes to your file. So here, for example, I will extract out the style, and we're going to put this in as a new parameter. So now I'm going to change the signature of this method. I will pass in the style. We can go to usage of this function, and we can, for example, change the font size to large. And you can see that within a second, we can now in the preview see the new change, even though we actually changed signatures. So these two versions of Live Edit work great in conjunction. Compose Preview also offers another feature, Interactive Preview, where we run a single preview composable inside the IDE. So let's run this one. When I click on it, we have a pretty neat transition effect between two images, and this is actually a graphics shader. This is a new feature in Android 13 where you can create a runtime shader where you pass in code to drive the shader. This code is in a new dialect of GLSL called the Android Graphics Shading Language. We have some basic editor support, such as the ability to uncomment and comment code. We have some validation of keywords. We also let you have parenthesis matching and brace matching, that kind of thing. Pretty basic. But with the interactive preview, we can use this as a playground to tweak our shader. So let's, for example, switch this dimension up to 548. You can see we now have larger squares. Let's rectangles, I should say. Let's click on this one. You can see even bigger. We can play with the randomness a bit. And let's also tweak the duration to 3500. So we can really sort of slowly see what's going on. So this makes it a lot easier to explore and develop my shaders for AGSL. Next to the interactive preview, we also have animation preview. All right, so we'll click on the animation inspector to load it up. And I'm going to turn on looping. We'll slow down the animation quite a bit. And now we can play it to view it. So here I can go in and I can explore the different curves, offsets, alpha, and so on. I can open up details for individual sets of curves. And with Compose 1.2, I can also go in and freeze particular curves. So let's say, for example, we want to not animate accessories, the accessories menu item, but everything else we animate. So now that this is frozen, I can sort of see how the other animations are moving relative to help figure out what's going on with my animation and to tweak it. Another visual tool to help with Compose is the Layout Inspector, and here we've added support for recomposition counts. So here's a simple example. Over in the Layout Inspector, we have two new columns, one for composition counts and one for skip counts. So if I go in the app and I click on this button, we now see that this text, which was incremented, its composition count increased by 1, whereas this other text, which was not affected, you can see its skip count incremented. And I can click the reset button to clear the counts if I want to explore that behavior again. The last thing I'm going to demo today is our new App Insights feature. We're working with the Firebase team to integrate data from the field right into your development environment. So the first thing I'll do is to log into my Google account. So I click on this login button, sign in, and then I can verify that I'm logged in. I've also opened the project which is using Firebase Crashlytics to collect data from the field. And now I'll just open one of the source files that I might be working on in this project. And actually you can see that there's this warning on this line here. And it's actually telling me that there is a crash on this line, and it's telling me that this is affecting nearly 6,000 devices. And I don't have to hunt around on my project files looking for these error markers. I can open up the App Insights window. Here's our crash. And here I can look at all the crashes for this app, sorted by number of events and devices. For a particular crash, I can look at a sample report. I can obviously go to the Firebase console for this. This is a sample report. I can also see a breakdown, on which devices are typically hitting this crash. I can see which versions of Android are hitting it. I can sort by version numbers of the app or collection times. And of course, I can click on stack traces to navigate to source. Now I already came from this location. We really hope that by bringing this crash data into the IDE for the Eng team, it will improve the fix rate because, the data is right there as you look at your own source files. But it's time to wrap up, and surprise, surprise, I didn't have time to show everything. We have improvements to C++ support, our games tooling with the GPU profiler and the Visual Studio plugin. We've been working on the coroutines debugger for Android. And of course, there's the regular merges of IntelliJ, the base IDE for Android Studio. And every version of that brings in a huge number of new features and improvements. So please use the canaries, please file bugs, and we hope you'll enjoy Dolphin and Electric Eel.
Now that you've had a taste of what is coming, I just have a few more updates on features that you just saw. First, I want to cover the impact of the changes we are making to the build system. Notably, when you use the updated build analyzer, we detect if you're using the legacy Jetafire flag in your Gradle.properties file and change it to false. From our analysis of opt-in insights, 80% of projects still use this flag. When you remove it, you can see 10% or more improvements on incremental build speeds. One last thing on build. Tor showed you the new baseline profile demo. Since launching this feature last fall, over 6,000 developers enable baseline profiles via the Android Gradle plugin. Depending on your project setup, some apps have seen upwards of 40% improved app startup time. Okay, that's it. To recap, we showed you a host of exciting features, both from Android Studio Dolphin and Electric Eel. From a new Logcat, tools for Wear OS, Live Edit for Jetpack Compose, and even device mirroring. Please try out these features to give your early feedback. As you know, you're able to run your project with both a stable and preview version of Android Studio at the same time, so check it out. Thank you for watching our session on what's new in Android development tools. On behalf of me, Tor, and the rest of the Android Studio team, we hope you enjoy what you see. Download the latest update today. Thanks for watching.